So in this screencast, we're going to look how to get started with the C++ development. So we're going to be using MSys for this, MinGW. So this is a compiler system available for Windows. So I'm going to launch MSys. This opens up this terminal window. And then if I type pwd, that tells us to print working directory. So I can see this is my home directory, and this is telling me where I need to put the files that I'm going to be using. So you can see it says /home /Craig Evans, and this actually corresponds to, on this computer it's installed, so in this MinGW folder I've got MSys and the version number and the home. So you can see my home folder's there. So I need to save files in this directory if I want to be able to this directory corresponds to my home directory on MSys. So I'm going to use Notepad++ to write the file. So I've launched Notepad++, and now I'm going to save this file in this directory. So that's file, save as. So it's already actually selected there. I'm not used this previously. So I'll just call it main.cpp. So it's important to select this CPP file type so it knows that it's a C source file. So now I've got this main.cpp. I've saved in directory. So now if I go back to the MSys window and type ls, that will list the contents of that directory. So you can see main.cpp. So I'm just going to write some code now. So I'll just do the hello world. So I'm going to do #include. So we need to include IO stream. So this is don't worry about the details now. This is just an input-output library what allows us to use stream. So we use a stream to print to this terminal window. So #include IO stream, and then int main. So this is my function. So all C++ functions start off in a main function. Again, don't worry about the details now. We'll cover this later. So this inside. So this tells us our function name. So all C++ programs and all C programs need to have a main function. And open curly braces and close curly braces. So this is where we need to put the code. So everything in between these braces is inside this function. So we need to use cout. So we need to, it's part of this standard namespace. So std : cout. Then note the directions arrows there. This is arrows for output. And we can put our message in here. So this is our string now, hello world. It's important to put the semicolon at the end. So pretty much all statements you'll be writing need to end in a semicolon. So now I'll save that file and go to here. Now I can compile it. So we compile it using G++. We can actually just do G++ main.cpp. That'll then start doing the compilation. So that'll convert this C++ into assembler, but convert it into this binary code what runs on the actual computer. So now I do ls again. So now you can see I've got this file called a.exe. So this is an executable file. So I can run that. So you have to put // in front of it. And that basically is telling MSys to look inside of the current directory. So our current directory is home and then my name. So if I go in that folder here, you can see I've got my main source file. Now I've got this executable. So I just need to tell it // in the name of it, and we run. We can see our message is printed. That's just very simple example of the kind of basic process. So you just write your source file, compile it. Assuming you've got no errors, it will compile. But for example, I'll delete this semicolon. I'll just resave, and I'll go back. Rather than typing the command again, you can use a cursor keys on your keyboard. So if you go up, using up and down, you can go back to previous commands you've typed in. So I'll find the compilation command again. I'll recompile it. He said no, it's given us an error. So in function main, expected semicolon before closing bracket token. So we know we're looking before this closing bracket token. We've got a missing semicolon, so we can go back. We'll see that we made a mistake. We can add it back in, save it, go back to here, recompile, and run the file again. So you can see, a.exe isn't a particularly very good file name. So we can specify the name of the file. So on the compilation command, I'll do -o. So this lets us specify the output file. I'll just call it main.exe. So now if I compile it, if I do ls to list the directory, we can see we've now got main.exe. So we can actually specify the name of the file, of the executable file. So I'll now delete a.exe. I don't want that anymore. So I can do rm a.exe. So that's the command line, the command for deleting files. So remove a.exe. I can do ls again, and you can see that we've just got these two files in. So there's also some other commands that often come in useful. So you can put -wall. And this that's saying warn us about, because we saw before what stopped it compiling before was an error. So if you've got an error in your code, it will actually stop it compiling. But sometimes you can have something slightly wrong with your code, and that will flag up a warning. So a warning won't stop it compiling. It'll still compile, but by putting this -wall command, the compiler now will warn us about any issues with the code, so we can go ahead and fix those before we compile. So now if I run this, there's no warnings here because it's obviously very simple code. There's not really much wrong, for example. But here, I'll create a variable. So this is a variable we use to store an integer number. I'll just call it int a. Again, I need to put the semicolon at the end. So again, don't worry about the details. We'll cover this later. But just for the time being, I'm just creating a variable. So now I'll go and try and recompile that. So now it's given us a warning. So you can see unused variable a. So that because there's nothing wrong with the code there. Code's compiled correctly. But it's good to put these warnings on, because obviously if you've got some real code, you've created a variable, but then you've not used it by accident, you've used the wrong name or something. This will tell you, this will give you a warning saying you'll not actually use this variable. So you can go back and check your code, make sure you've not made any mistakes. And then there's another command that's also useful. So I'll just go to add in. So this is this -o for optimization. We can give it different levels of optimization. So O2, the kind of second level of optimization. So again, it's not going to make much difference to this. I've still got the warning. So I'll go back. I'll just delete the integer there. Then resave. Go back. Recompile. So every time you make a change, you need to save it and recompile it. So now we've got no warnings, but this is going to be optimized. So it's not going to make a difference for this because the code's so simple. So you run it, it just prints main.exe. But when you start getting longer code, you might want to optimize it, make the size smaller, or it can make it run more efficiently, run quicker and things. So it's a good idea to use these two flags when you're doing your compilation.